Hi there, and welcome to a very interesting episode of The Inevitable.
Yes.
This is MotorTrend's podcast, our vodcast about the future of the car, the future of transportation. Ed forgot to ring the bell. We don't have a sponsor this week. However,
yes,
man, do we have a guest?
we do have a guest. I'm not doing a read right now. We're going to skip the question. We're going to go straight to the guest, Ali Javidan of Range.Energy, and so much more. Tesla, Dinan, Zoox,
Ground control,
Google. I guess I wrote about him in Sport Compact Car back in like 2005
and
or 6.
We went 30 minutes over what we're supposed to do, and we didn't even really
get into it.
Yeah.
So,
but he has a company, Range.Energy.
Range.Energy. It's all about the future of electric commercial long-haul trucking, Class 8 trucks. But before we get into that, we're going to talk all about him and where he came from and his awesome, amazing existence. So, without further ado, let's talk to Ali. All right. Ali Javidan from Range.Energy. I've heard so much about you, mostly from this guy.
Let me set the.
Do you want to do the first part about how we got here?
So
who's this guy?
Pebble Beach. So a lot of people wonder what goes on at Pebble Beach. Are you just talking about cars the entire time?
No.
The answer is yes, really. But so I'm having cigars at the fire pits at Spanish Bay, like my favorite thing to do. And my buddy Matt Farah's there, and Matt's like, "Bro, you got to get this guy on your podcast." And I'm
That's a good one.
Thank you. And I'm like, "Oh yeah, why?" And Ali started talking, and I think I even texted you, like, 4 whiskeys in from the fire pit, like, red alert. You got to get this guy.
Cool story.
That's flattering.
Yeah.
And here we are
And Ed ignored
December.
it.
Here we are in
Well,
December.
hey, man.
Just in time to book the hotel for Car Week next year.
Exactly. So, Ollie,
yeah.
I've heard a lot.
You got to check this guy out.
Tesla, Zoox, I just heard Google, Dinan.
Who was before
Toyota.
Dinan? Ground control, suspension?
Oh, mountain bikes?
No.
No.
Oh, the other ground control.
Ground control suspension.
Got it. Okay.
Honda, BMW tuning.
Right. Sorry, I went to a dark
Toyota EV.
Yeah.
The
Toyota.
RAV4
So
EV.
where do we start?
Where do we-
Ali Javidan of where? Grew up where?
So I grew up actually just outside of Sacramento, California.
Oh, my wife's from there. What?
Auburn?
Elk Grove?
Folsom area,
Folsom.
specifically Orangevale, which is a little town next to Folsom.
Okay. All right.
Been through it.
I grew up in a family of immigrants.
Okay.
From where?
From Iran.
Okay.
And my uncle, a few of my uncles, but specifically one of my uncles who had a son that was exactly my age, owned a mechanic shop.
Okay.
And I had just always been into Hot Wheels and all of this stuff. And growing up, I was just like, I want to be doing something with cars. Graduate high school, go into junior college, trying to figure out what I wanted to do. Got pushed into civil engineering because it's a good, steady job for an immigrant child.
Sure.
And then you could do whatever you want after you're done with your state job in the afternoon. Did that for several years. I basically came up to my civil engineering degree, took the state licensing test, and I was working on bridges at Caltrans, doing bridge retrofits and designing new bridges up in Northern California, mainly in the Sierra Mountains on the 80 and the 50 corridor.
Beautiful work.
It was incredible.
That's awesome.
2 years of living on Donner Lake, fishing every single afternoon for rainbow trout. It was spectacular.
Gorgeous, yeah.
But I got the funniest thing. I got a bit tired of doing roadway work, and it was really, honestly, like I had seen 2 people die on the roads.
Yeah.
I'm standing on the roadside, measuring concrete and looking at rebar and all this stuff. Meanwhile, trucks are driving by at like 70 miles an hour.
Caltrans, well, I've always heard, pays extremely well. Is that true? Extremely well for that type of work.
I would say that the base salary is the same base salary that you would get pretty much anywhere.
Okay.
But what Caltrans did for me at that time was that they said, here's a strong daily stipend. Here is your rental allowance. So I was able to live up there completely expense free. They gave me a car, all of that stuff. I was able to do everything I needed to do so that it kind of, that's where all my extra money came from back then.
Okay. Gotcha.
And so, anyways, I did that for a long time, and I had this crisis that I was like not going to be happy with my career at Caltrans.
Quarter life crisis.
Yeah, let's say quarter life crisis.
Okay.
I went back to my faculty advisor at school. I studied at California State University, Sacramento.
Yeah.
I went back to my advisor, and his first comment was, "Hey, Ali, you need to be making weapons, not targets. And I was like, what do you mean? And he said, civil engineers make targets, mechanical engineers make weapons.
Interesting.
Go make, and you know, I'm like, I'm not like a war type of a person, but it kind of clicked for me.
Sure.
And for me at that moment, it was race cars. And I saw the school Formula SAE program. And from that moment on, it was just race cars. So long story short, went back to school, took the last 2 years of school all over again, now in the mechanical engineering domain, joined the Formula SAE team. Within a year, I became the president of the student SAE club and ran the Formula SAE team. We did really, really well. Out of college, then I got recruited by Ground Control.
Real quick, what did your immigrant parents think of you giving up the good civil engineering job and going back to school to play with race cars?
It was still an engineering job.
Okay.
And I still had my civil engineering license.
Got it.
And so my parents were just like,
ding, ding,
you
ding.
got your fallback.
You're a young man.
You can sign off on drawings now. Worst case scenario, go back to your state job. You'll be okay.
It always need roads.
Yeah.
You're how old when you get out of mechanical engineering? It's your second degree?
When I finished mechanical engineering, it was 2004. I was 29 years old.
Okay. All right.
And before all of this, I actually wanted to be a photographer. I'd won a bunch of national awards for landscape photography out of high school.
Well, so you must have loved the Sierra.
And I had a scholarship to Academy of Arts College in San Francisco to start up their landscape photography program with them, like all of this. But my dad was like, pause.
Yeah.
You can buy cameras when you're making money from state funds.
Sure.
Oh, wow. Was you a camera nerd?
I'm a big camera nerd.
Oh, this kid out here watching stuff.
I used to shoot 4x5 film exclusively, and now I do mostly medium format digital.
So that's how you get poor, shooting.
Yes,
medium format.
exactly.
Yeah. Before we get into the deep in the car stuff, just because I don't think there's any other way to circle back to this. You've spent a lot of time looking at bridges and rebar and concrete and retrofitting old bridges.
Yep.
Do you have any thoughts on the aging infrastructure of this country and all this fear of these heavy ass EVs? And if everybody drives, there's an argument. We actually talked to the Gensler guy about this. Yeah. If everybody drives an EV and they all weigh X percentage more, I know you're going to say they don't all weigh that much, but your Rivian does weigh a lot more than
average goes up.
Yes.
No matter what you think. That I drive an R1T also.
Right.
But the average goes up.
Do you have any? Have you ever thought? Do you think about? Do you like consider like, oh man, I wonder what?
I think about it literally every day, every mile that I drive, because I do have a really deep scar. When I was up in the mountains working on the 80 corridor between Truckee and Reno, we got an emergency call one day from the CHP saying there's a hole in this bridge, and the bridge roadway surface had finally crumbled to show that the structure beneath the roadway was gone. And the surface was falling into the river below, and so that's like a demonstration.
It's like Warner Brothers.
And what it was after an expansion joint on the road surface, and there's trucks going on the 80 corridor all day long.
But when you say trucks, you mean big rigs.
Big rigs. Now, hold on. So that takes me to my point is that the average load across the road is not a problem. It's these point loads. When you get a big rig that needs to get loaded with 8 or 12 EVs, and that big rig is asking for a 20,000 pound allowance over its 80,000 pound normal weight.
Right.
Now that 20,000 pound allowance is what's putting those point loads on those axles. Now, if you think about states like Washington or other states that offer that allow multi-axle trailers, 3 or 4 axle or 5 or 6 axle trailers, or in Europe where the 3-axle trailer is standard, that's where you see a lot more leniency around being able to load these trailers up high. But on net, passenger vehicle, filling our roadways, you could put, back-to-back Hummer EVs on the Golden Gate Bridge, and yes, it'll flatten out, but it's not going to be any problem. It's really those concentrated point loads from commercial vehicles that are causing the roadway surface problems.
Yeah, my dad always said that to me. He always said that like semi trucks are the only things that damage the roads.
Yep.
He's like,
I like this guy. Let's get him on the podcast. All right. All right. That's fascinating.
Okay,
so bridges, you're fine. Okay. Ground control.
So went to ground control, did a bunch of racing, worked on touring cars, got moved up from ground control, went to Dinan, worked on more touring cars, left Dinan because Steve and I are still friendly, but can't work together very well.
It's like me and him.
Yeah. Went to Time Attack, spent a bunch of time with the Japanese folks working on Mitsubishi Time Attack cars. And right about that time, I was getting burned out. And around 2000...
Just from the lifestyle, the racing lifestyle?
Just the racing lifestyle.
Yeah,
You're like never home on a weekend. It's it's exhausting. And especially...
Bad food, bad motels.
This was the beginning of Time Attack in North America. So the first global Time Attack, we won it in our the Cyber Evo. Was the car that we built.
Cyber Evo?
Yeah.
We did cover that in
Tarzan Yamato was the driver. Yes, you did.
We did a write-up in Sport Compact Car.
Yeah. You also, Sport Compact Car did a bunch of write-ups on my suspension from ground control too.
That's right. Okay.
Yeah.
Good guess, huh?
Yes.
That's crazy.
Yes. Yeah.
Just wait.
Shout out to Sport Compact Car.
Yes, SEC baby.
So yeah, it was just an exhausting lifestyle, and it really became like, do you want to move to the UK to work in F1? Do you want to move to North Carolina to work in NASCAR, or you want to go to Japan to really take on Time Attack globally? And I just didn't have the appetite for any of that stuff.
Right.
And so I decided to kind of settle down in Silicon Valley, where my girlfriend at the time, or my fiance at the time, had gotten a job at a small search engine startup called Google.
Oh yeah, I heard of them.
And so I said, okay, I think this is going to go, literally, this was pre-IPO. I said, I think this is going to be good.
Girlfriend at the time?
Fiance at the time.
Fiance. So we're still married.
Oh, good.
But that's a whole different story.
Yeah.
So you're rolling.
I'm not rolling.
Come on.
I'm not rolling.
Soon
we're gonna talk
Wait
about.
till you hear the story.
Okay.
Yeah. Wait till you hear what he's selling.
So anyways, moved to Silicon Valley, took a standard job working on some manufacturing line, designing like little process equipment thing. And I got a call in the middle of the night from a guy named David Vespremi.
I know David.
So David calls and he says, "Hey, Ali, we worked on the Time Attack car with K&N together. He used to work at K&N.
Yep.
I'm at this new little startup and there's just a few of us and Microsoft is coming and the car handles like, and you're the only suspension engineer I know around here." I went there and it was a garage in Redwood City and it was the red Tesla Roadster first one.
Nice.
They couldn't figure out how to get it to work. They didn't want to pay Lotus to come and re-engineer a bunch of the suspension. And this was one of their first mules that they had basically just converted a Lotus.
This 2007?
2007, yeah.
Late 2007. And basically I came in and I used all of my suspension knowledge. And at that time, I still had access to the shock shop that I had at Sonoma Raceway. I still have a shop at Sonoma Raceway.
Gotcha.
So I took the shocks off of that Lotus. I went and revalved them. I changed a couple of little tiny steering geometry things on the first Roadster. And then that became the new kind of setup for Roadster. And basically that, the Microsoft commercial went well, and like all of these kind of press things went well. And then in early 2008, they said, "Can you come back?" And over the course of about a month and a half, they interviewed me, and then I joined in 2008 full time.
They being who?
The Tesla team, the original small core Tesla team.
And so this is before 2007 is before Elon.
Before Elon. So I joined a month later. Elon kind of took over everything, and that whole situation happened. And then there was a month after that, there were layoffs and all of this. And
right.
through that, all that kind of turmoil is when Franz and his team were hired.
Right.
Elon needed to build something to go raise the next funding round off of, which was the sedan.
Right.
Back then we called it the White Star.
Right.
You remember Roadster was Dark Star.
Yes.
Model S was White Star.
Yeah.
Model 3 was Blue Star.
Yeah.
And next generation Roadster was supposed to be Dark Star.
Okay, so wait, did Tarpening and Eberhard, did you interview with them, or was it like were they
with Martin,
mostly
with JB and the original?
Oh, so JB was already there.
Yeah, JB was there from day one.
Oh, right, okay. Yeah,
JB was there from day one.
Okay. JB Straubel.
JB Straubel, yes, who is now the founder and CEO of Redwood Materials.
Yes, who we're trying to get on here.
So we're gonna get him on.
JB was my hiring manager.
Got it.
So because it's topical, like when this Elon guy shows up, what was your initial impression?
Man,
forget about what it's like
crazy
now.
Time.
What was that like?
So you have to remember, I'm like a month and a half into this. This is my second startup. I came out of the racing industry and then into Silicon Valley. And there was just kind of this whole weird like scene where in the racing industry, pressure is everything. Deadlines don't move. You have to perform, because if you don't, there are 11 other teams that are going to perform.
That will beat you.
And they will beat you no matter what. So you have to show up no matter what. And so I came into this with that mentality, and there were almost nobody else in the company kind of had that like impatience. And then when Elon kind of started to take over, he started to ask kind of like, who are the superstars here, and who do we look at kind of moving on or whatever. And that's when that first big round of layoffs happened.
Right.
At the same time, that's when we were fundraising. We were getting ready to fundraise for the next round, and we needed that sedan. We needed that kind of next thing. And there was this mix of emotions of like, who is this like PayPal guy that's showing up and just fired the guy that the founder that we all look up to.
Right.
But then also by that time, there was this kind of undercurrent of frustration that the Roadster wasn't shipping yet. And it was just problem after problem and quality problem and production problem and all of this stuff. And so there was a big hope that Elon is going to show up and help us fix it. And we had a couple of interim CEOs. We had Mark something, I forgot his name or something.
Oh, yes, I do remember that.
And then we had Zev from Clifford or Clarion or something like that.
Yeah.
And so...
oh yeah, I hadn't thought about that in a long time.
Yeah, and so there was a hope that, okay, well, Elon, he's going to just take all of this seriously and just fix a lot of these quality problems. But there was this still kind of like, we're not sure. What flipped? The moment that everything flipped was Elon hired Franz, Dave Morris, and the entire studio team. At that time, he pulled me out of, I was designing like dynamometers for the motors that we were building for Roadster. He's like, that guy's got race background, and he kind of pulled a few folks together and built this like crazy R&D team. So I led the vehicle platform prototyping. Franz and Dave Morris led the studio team. They took Heinrich Fisker's not good at all design, made it look beautiful like it is today.
Yeah.
And then we were building the platform, and our job was basically build us a freaking electric sedan as quickly as possible. What we all knew was Mercedes, because I had a bunch of BMW Master Techs and Mercedes Master Techs on my team at that time. And so back then there was no like Motec or these engine. You couldn't buy even Arduinos and microcontrollers. Mm-hmm. Everything was done manually or analog or whatever. So we chose the platform that we knew the best, which was the Mercedes E-Class. And the CLS had the silhouette that was the most, other than the Aston Martin Rapide, which wasn't even out, but the CLS had the closest silhouette to what the Model S was going to look like.
Right.
And that became the kind of geometrical blueprint for Model S.
So I was at SpaceX, and I think it was 2008 or 9, when White Star Model S very slowly rolled out, and somebody's like, that's an E-Class. Like how much E-Class was in that thing?
That was me driving that car.
That was you driving that?
Yeah.
Really?
Yeah.
That was wild. I remember I actually, that was the first time I met Elon, and I interviewed him, and he was just out to lunch. He was like so exhausted. So crazy.
I mean, that you have to remember at that time, all of us, this was, especially in that moment, was 3 weeks of literally no sleep. We had cots around SpaceX where people would go hide and sleep for an hour or two and come back.
Sure.
And Elon was there around the clock.
Yeah.
So how much E-Class? So what we did was we wanted to start with, first, what does an electric sedan feel like?
Right.
What does a Roadster powertrain, which we have engineering models for, physics models for, feel like now when we up the weight, up the vehicle geometry, all of that stuff? So first was get a CLS and an E-Class and figure out which one you want to integrate, and integrate one of them as quickly as possible. So we went down the street to Autobahn Motors in Belmont, California, the land of the E63 wagon on display, and bought a CLS. Essentially, then in parallel, I had a team taking a Roadster powertrain apart, the battery and everything, all those 11 modules, make it flat, create a flat battery pack, take the Roadster motor, redevelop or change the oiling inside the motor so we can lay the motor down now, so we can put it in the differential pumpkin area of the CLS, cut the entire floor out of the CLS, reinforce the body of the CLS, graft the entire powertrain, some battery and electronics under the hood, and then everything else in the floor and in the rear trunk space under the floor, re-engineer the suspension, get everything working right, remap the gauge cluster, all of that stuff, and build the first electric sedan in the world.
Right. Wow.
And we did that first car with a Mercedes body on it, took about 4 months.
Wow. Okay.
Which was very fast. Nobody had ever done anything that fast ever.
Yeah.
By the time this prototyping team was good at what we were doing full electric conversions with full CAN bus reverse engineering. The fuel gauge was state of charge. The RPM was power meter. We would re-screen print the gauges. You would get in the car and it would look and feel gas until you started driving. We could do that in 13 days. That was the fastest we did a car.
Wow.
Huh. So that was the first. That was literally the first mule.
That was the first
White Star for Model S.
That was the first Model S mule.
And were they driving around the street?
Yeah, so that was it looked like a Mercedes, and we primarily used that to fundraise. That's where we got the Mercedes investment. That's where we basically demonstrated to the investors that this is what a sedan is like.
Right.
We used that for fundraising, and then in parallel, as soon as that first car hit the ground and we started driving, we went out and bought a second CLS and did that whole thing all over again and didn't make it look pretty. We took the skin off of the car and shipped it down to Franz and his team in Southern California. Then they made it look beautiful. And then our entire team moved down to Southern California for a couple of months while they were doing all of the A-surface beautification on the outside.
Right.
We would come in at night and make sure everything worked again, plugged everything back in, and then do our development. And then by 9 o'clock in the morning, we had to be all unplugged, battery pack out of the car, and then back. And then they could be back welding, grinding, bondoing, carbon fibering on the body itself. And we did that for 2 or 3 months until that show car was done.
This was a Tesla design right next to SpaceX.
Nope, this was in a tent in the back corner of SpaceX before we had our own design studio.
Right.
Inside the back corner. And that gray Model S that rolled out that day was this second CLS.
That was the second CLS. Okay, so it wasn't even. I mean, the CLS is
so
a
many
modified
crazy
E-Class.
stories. So there was a bunch of tells. If you look at that car, and now that car is now in the Peterson.
Okay.
So a bunch of tells. So the wheels on that car were originally inspired by the Volkswagen. What was that Volkswagen CLS thing that they made?
Oh, the Ayrton?
Phaeton. No.
It's called the CS or something like that.
Yeah, the CS. Volkswagen CS?
Something like that. So it had those turbine wheels.
Right.
And then we wanted those turbine wheel, that design on Model S. Lorenzer made those turbine wheels.
Those are Lorenzer wheels?
Those are Lorenzer wheels with the Lorenzer logo sanded off. And body filled.
Google Lorenzer bad body kit S-Class right now.
Performance CC concept.
The
CC.
The
Volkswagen CC. Because that came out in 2006.
Oh yeah, they're kind of like Aero. They're kind of like
CC
Aero
wheels. That's the original inspiration for the
Okay.
Model S wheels.
Okay.
Turbine. Oh yeah. Okay.
Okay. Yeah.
All right.
So, anyways, that was the beginning of the thing, and then from there, we basically split my team. One part of the team would support Franz and all the design activities with subsequent Model S's. And then we would also run the alpha program of the prototypes and then help hand off the beta program to the production team in the factory. And then in parallel, we were working on other projects like powertrain projects. Because you remember Tesla in the early days, over half of the revenue was from powertrain sales, third-party powertrain sales.
Right.
Looking for the best off-road trails? OnX Off-Road has you covered. With over 750,000 miles of trails and comprehensive offline maps, you can explore without worrying about cell service. Easily find trails for 4x4s, ATVs, dirt bikes, and more. Our app provides detailed trail info, including difficulty ratings and open/closed dates. OnX Off-Road also helps you navigate public and private land boundaries, ensuring you stay legal. Try OnX Off-Road free for 7 days and discover why it's the go-to app for off-roaders. Download now.
Real quick though, before we move on from that day, the model, like how did it go in your mind? Because I remember very clearly, the journalists were of two opinions. One was before the thing rolled out, I had no idea you were driving it. That like this is just vaporware, it's garbage.
Yeah,
and then,
PayPal guy, what does he know about building cars?
But then when it like showed up and it really was a good looking thing. I mean, you know, and it, you know, and again, you have to remember there was no Model S then.
Yeah.
Like, you know, I remember a lot of us were like, whoa, like that's an electric
sedan
car.
That looks good.
That's not the Roadster. And you were claiming like at the time, like, I don't know, 250 miles range.
250 miles
which
range.
seemed insane.
Yeah.
Like insane, you know, like. So anyway,
so one thing actually, just to back up a few steps, when you asked kind of what was that like that moment where us early people at the early team at Tesla leaned in and said, hell yes, Elon is the one to take us there.
Right.
Was when a few of the folks started to go visit SpaceX, and you start to see SpaceX and you're like, wait a second, he's not just some PayPal guy.
Yeah.
This is way more than that. And then people would come back to Tesla and say, when you would hear hallway conversations about, is Elon really going to be able to do this?
Yeah.
Like, hey, dude, like I just got back from SpaceX. That place is freaking crazy.
SpaceX is wild. Yeah, it's totally wild.
Yeah. So anyways, so we knew when we drove that first CLS, we knew we had something really special. And then that first Model S, I mean, for us, it was the same thing. Like we had seen it, like driving around. I have photos in my pocket of like all the different stages of us driving it and all of this stuff. But until that was real, where you can like play the radio and like close the doors and roll the windows up and down. And yes, it was just a reskinned Mercedes CLS, but that feeling of having 4 people in the car, and it went from like, this is a clunky electric conversion, or this is a refined electric sports thing that's been converted, to like a fully built out product. And this, you have to remember, no matter what we say about that era where people were comparing us to the Volt or to the Leaf at the time, or even the Fisker.
Yeah.
This was Mitsubishi i-MiEV.
Oh, the i-MiEV. Other than the i-MiEV, this was the only, and the EV1, this was the only ground up vehicle platform to be built for electric. The Leaf was a Nissan Versa. Right. Like everything was something else.
Yeah.
And so this was the first time that we could really realize as an automotive industry what happens when you start to think about this vehicle to start electric and be electric from the beginning.
So we've heard a lot about Tesla. One of the first things that really blew me away, besides the electric part of Teslas, was that the over-the-air updates were like massive functionality changes would happen, and the car would get better the longer you owned it. And we've heard that like that happened because nobody would work with you guys back then, and so you had to write all your own software anyways. That's right. And then it was, hey, we write everything.
Yep.
It's easy to upgrade. Is there any truth to that?
It's a combination. So there's definitely some truth to that. So you have to imagine we're a bunch of like Silicon Valley startup laptop folks that know a little bit about batteries, and all of a sudden now we claim to know cars. And then we call Bosch and Continental and ZF, and say ZF or ZF,
right?
Whatever.
ZF.
And you call them and you say, hey, I'm building this like sedan. We don't really have money. I don't know how many I'm gonna sell, but I need a full body electronic suite, kind of like what would be in an S-Class. Thank you.
Yeah.
And by the way, hang up? Yeah.
By the way, my CEO is crazy, and we want to be able to write all the firmware and the software, and we want to be responsible for everything. So many doors got slammed.
Right.
And so we ended up having to go to a small scale body controller supplier for those first Model S's. The first generation Model S had exactly the same body modules as a Ford Fusion hybrid.
Yeah.
Carryover.
Wow. Really?
Plug and play carryover.
Wow.
And it was that Pectron was a supplier back then that made all of that stuff. And we couldn't get the attention of the big guys.
You were probably getting paid you had to pay a premium.
Yeah,
to Pectron.
we had to pay everything.
This is the same as Rivian. When RJ was on, he's like, dude, we could not get anybody to answer us. And they were paying so much more than the big guys, because the big guys are dealing in volume.
And you would get the crappy engineers, and everything would take a long time. And when you would ask for some firmware change, they would laugh at you, or they would have to like double and triple check why you would need this firmware change or whatever.
Right.
And so when you start to stack that up, and then you realize, well, at the end of the day, again, we're at that era where like Arduinos are starting to come up, and microcontrollers, and like all of this maker stuff is getting commoditized. And now we're like, well, wait a second. This is just a controller with like a CAN chip on it. Like we can just communicate to this thing. Right. And we're all computer engineers back in our previous lives. And so let's just build this stuff from scratch, because then we can control our own destiny here. And in fact, we can build an integrated system.
Right.
Because the challenge is, you have to remember, even today, when you're Mercedes-Benz or Daimler and you have an S-Class, the amplifier in the infotainment system is made by a completely different supplier than the guy that's controlling the taillights.
Yep.
But was there pushback when you said, all right, we're just doing everything ourselves? Was there any, I don't know, automotive industry veterans who were like, whoa, like, don't do that?
Yeah, they all stood back and laughed at us and said, good luck.
Yeah.
Okay.
There was no pushback because we were just like, you're in our, the only.
Was there internal pushback? Anyone at Tesla who knew better?
No.
Okay.
No, because anybody that claimed that they knew better would get exited from the company. Peace. Yeah. You had to have an open mentality. You had to have first principles thinking at every single juncture.
I'm glad you. So that's not bullshit. So Elon gets a lot of credit or flack for. So he's truly the first principle.
Absolutely.
Can you explain to the people who don't know what first principles are?
I don't know what that really means.
So I'll give an explanation that may kind of be a little bit too much in the weeds, but early conversations of Model S, we were talking about how we could beat the M5. The M5 was one of the first performance benchmarks that we had. I think it was the E39 and then the E60 M5.
Yeah.
Yep.
And then we were thinking about the next M5. What came after the E60 M5?
F30
M5. Yeah. And so we were mid E60. And I had come from Dinan where we were doing
the F80, right.
We were doing the 6-liter M5.
Right.
And I'm like on Monterey Highway with Steve Dinan doing 200 miles an hour. And I'm like, we have to build a car that's faster than that.
Right.
So, and Elon is like, yeah, we can't be slower than an M5. Like he's the one that led the charge on this, right? Because he's driving a 997.2 Turbo S daily.
Right. No, I remember when I interviewed him, he was saying like, this is back at that event. And I said like, so why is it so quick or whatever? And he's like, well, I have a Turbo S, but I have a lot of kids, so I want to put like my 5 kids. You only had 5 kids.
He's like, I want more seats, not a slower car.
And I'll never forget. I said, so are you like a car guy? And he's like, no, not really. Oh, I had a McLaren F1, but no, not really.
Yeah, that's pretty good Elon impression.
Thank you.
Yeah,
I'm good at impressions.
He appreciates those things. But anyways, so the example of this first principles thinking was we were looking at the M5 performance numbers. And we started to talk about what do we need to do all the way down to how much current do we need to flow through these chips in our inverter to get to the power that we need to be able to put it down to get to a 0 to 60 time in 3 seconds or whatever it was.
Yeah.
And so we would do all of these studies and Drew, who's recently just left Tesla, Drew Baglino, who I would say is one of the smartest people I've ever met. Drew would do all of this modeling and he would say, theoretically we could get to 1.70 to 60 with tire grip and mass, which is where the new cars are now.
Right.
But today we could get to this much because of these things. And Elon would just say, well, why can't we go faster? Well, we're not at tire grip limit.
Right.
Why can't we go fast? Well, we can't flow more current. Why can't we flow more current? Well, is the cables too small? Are the cables too small? No, it's this chip. We can't get enough heat out of this chip. Well, what's the substrate? Well, the substrate is alumina. Well, could you use silicon carbide or some other substrate that's better at heat rejection? Well, yeah, but it's not available and it's just kind of university. Okay, well, if that material science is the fundamental problem, go hire a university, make the material science better and put a better substrate under that chip so that we can get to the core. And the thing is that suppliers don't like that. Mm-hmm. Suppliers want to sell you what's on the shelf that they've been building for the last 2 years.
Right. Or get a huge contract to build
or get a huge contract, but then you're at the mercy of the supplier, exactly. And that supplier is always looking for other people to sell that thing that they're making for you to make some money on the back end.
Right.
And so that's where a lot of this came at. And the only real supplier that we were kind of cuffed to and really needed to use for legacy information was Bosch. And that was really on the brake controller and the ABS system, the iBooster. Bosch had just productized the iBooster by that point. And in fact, we kind of induced a complete revision change in the iBooster to the next generation of iBooster because
what's an iBooster? What is that?
iBooster is basically a standalone brake control ABS controller. That Mercedes and Bosch came out with, and I started getting used. Now everybody uses the iBooster.
Okay.
It's an all-in-one unit with its own accumulator and boost assist and ABS controller and module and like all of this stuff built into one little box.
Okay.
It works perfect for electric cars because you don't need a vacuum source to get power assist.
Right.
The electric cars at that time, we were using I was using a second generation MR2 electric steering pump, and
to create pressure.
To create pressure for the power steering.
That's hysterical.
And then just a weird little vacuum pump that we had to have vacuum for the brakes. But when iBooster came out, we started using that, but the processing in the iBooster wasn't fast enough to respond to the response time that we got from the electric motors.
Oh, interesting. Right.
The electric motors were able to respond to torque requests so much faster than anything Bosch had ever experienced before.
Sure. Yeah. I mean, people forget you can just do whatever you want with an electric motor.
There was a mix of a bunch of different things. And I think still the iBooster is still used or maybe not used or whatever. But the whole idea there was that we didn't want to go through all of these different layers of complexity to be able to make the door actuation more smooth for a customer, because all of this boils back down to the experience. Right. And at the end of the day, Elon or Franz would walk up to the vehicle and they would feel that experience. And when there's a disruption in that experience, or if there are too many steps to get to a menu or something like that, that's when they raise the red flag. And they would never say, fix it this way. They would just say, fix it. I don't want to have 15 steps to get to the seat heaters.
Right. Okay.
And was that how? I mean, we're gonna run out of time.
Yes. Yeah.
But let's fast forward.
We haven't talked about range yet.
We should. I mean, we can make this a two-parter. He does have a company he is pushing, called Range. Fast forward to this car magazine called MotorTrend gives the vehicle car of the year.
Were you still there? You? Oh,
yeah.
Did you go to New York? You didn't go to the party in New York, did you?
I left in 2012 before the MotorTrend party, but I was there for the test that got it the car of the year. When I forgot who the team was, but when they first came to the Fremont factory before
Kim Reynolds.
It was the whole team. They came out to the Fremont factory before we had occupied it, but we had possession, but we weren't in it yet. But I had resurrected the test track, and we were using that test track for a few different things, and the MotorTrend test was one of the first.
So how did that, obviously you put a lot of blood, sweat, tears, time into the Model S, and what was that like? Were you like, they get it, or what did you like?
Yeah, we did one gut check test before MotorTrend showed up and discovered a few little things in the suspension. Basically, the chassis team and myself just spent a bunch of time just driving the car, going over bumps, just feeling all the little like nuanced things. And we were very, very lucky that we had an incredible benchmark fleet, like Audi S8,
7 Series?
BMW 7 Series, Mercedes S-Class and E-Class, the A7, Audi, Porsche Panamera, Jaguar, whatever it was.
XJ, big XJ.
Yeah.
Great car.
XF?
No,
the
XJ
XJ with the steering. It had like really special steering.
Yeah, it was great. I love that car.
So we used that Jaguar for the steering.
Nice.
We used the Porsche for the chassis controls. We basically kind of put this hodgepodge together, and we would drive a course, and it was almost kind of like process of elimination. And we would just be like, all right, take the Panamera on here because this is all about chassis control. And we would just go do this loop and come back and try to match it with the Model S, and then take that same Model S and go do the steering loop with the Jaguar against the Model S. So we did a bunch of that. It required a few bushing changes, some simple stuff, a bunch of damper changes. And then that ended up becoming the P90 Plus.
Right.
Or P80 Plus, the first generation. P85 Plus.
P85 Plus, that's right.
The Plus was the MotorTrend suspension calibration.
Got it. That's awesome. So how was when you heard the news? Like how?
Where were you? You had left.
How did that go down?
Now, why'd you
I had
leave?
just left. I was
burned out.
I was in Tahoe. Yeah, I was there for 5 years. Didn't have a day off. And it just I took some time. So first Model S shipped, and that's the day that I just said I need a break. And it was it was mutual. I think we both kind of like. At that point, I was, casual and around with Elon, but a lot of time was spent with JB, and we were really kind of growing the company up a lot. The prototyping team, we wanted to move the center of gravity of that prototyping team from up here north down to Franz's area in And actually we're down south now.
We were down south.
Down here.
Yeah.
And it was just a good time for me to kind of take a break. And I took a break from Tesla. I took about a month off, and then this team at Google called and they said, "Hey, we heard you may be available. Come." And Google recruited me right after that.
And personally, were you like married?
Yeah, I was married. I had one kid and the second kid on the way.
Okay.
But how did Tesla feel about? We know how Franz and Elon felt, but how did the troops feel about the award? Was it?
It was one of the most prideful moments, I think, in the company's history. Everybody was so proud, and I was incredibly proud. I was really bummed that I wasn't able to get a photo with the award.
Oh man, I could have brought one.
Yeah,
it's all right.
It's
okay.
That's literally
got a bag of them. Next time.
I think everybody was proud. It's just there are these. As you develop a product, especially a product that in your heart is going to be important, and you start to see that everybody starts to see that it's important as well.
Right.
I had a few of these moments. So the first real moment was when somebody like you wrote about the car, and I just saw a photo of me sitting in the car in a magazine, and I was like, crap, like this is, I've had my race cars in like Sport Compact and all of this stuff, but that was like, this is real. That was one of the first. And then the next big one was when I was driving and I just saw a Model S in the wild. I didn't know who the person was. It was a customer.
Right.
And it was just, for me, it was like so crazy. And then there's, there are all these other moments. So you just kind of think about everything that the teams accomplished together to bring this vehicle to the market. I really do believe, like, up until we got that Model S going and it started to go into production, like 2012, 2013 was really kind of that moment when I started to see that car come off the line, even though I wasn't there, where the first time I thought, holy crap, this is a very important car. Like, this is really, because then you start to see the response of everybody else in the industry changing.
It was a slow response.
It was a slow response.
Slower, in hindsight being what
2015 is when the tide started to really turn.
Well, I feel like it was, I tell people, because look, I love it. Then this is very flagellating for us. Like, tell us how much.
We were 2 of the 11 people that voted for it.
Exactly. Tell us how much you love us.
We were there. No, but we were. It was, for us, it felt like a historic moment.
But our leader,
but remember how it was? Like Chris Theodore was like he's like, the car's perfect, but the business plan makes no sense.
It's a moonshot, the whole thing. And our leader at the time, Angus McKenzie, was on record numerous times. Like,
Angus, he was there.
Yeah, Angus was there. And Angus was famous for pooping all over it. What was a PayPal guy now? Silicon Valley's going to learn a thing or two about hitting up Detroit. And then we drove it. And we're like, holy. Yep. And that was every. It was, you could watch
Dan Neal was brutal too.
Yes. Yeah. Watch the tide change when you actually get behind the wheel. It was the New York investor crowd. That's why we did the party in New York.
Yeah.
Christina Ra, the PR, was like, we got all you automotive journalists in the bag because you love cars and you know what this car's like to drive. It's all these dummies over here in New York who think a car is a yellow taxi cab.
But we were so skeptical up until we voted, because I remember we do the vote and it's
unanimous.
Unanimous. First car of the year. There's been a truck of the year that was unanimous, but as far as I've been involved with, first unanimous ever car of the year. Hands go down and we're like, whew. And then I remember I said, who here has ever publicly or privately said this thing's vaporware that we just voted car of the year? And 10 of the hands went up. This guy's didn't. And I looked at him and I remember never he said, hey, my mom said if you have nothing nice to say, don't say anything. And it was just like, it was a real, like, for us, like, eating crow moment.
Yeah.
Because there was so much doubt, because I walked away from the SpaceX thing where I was like, oh, it's just they put an electric motor in a Mercedes. Big deal. That was I was young and stupid, but
No, I mean, you could definitely see it that way.
Yeah. Because it drove real slow.
Well, no, the first one was relatively fast. Like
you drove it in front of us real slow.
I drove it slow.
Okay. So I blame you.
You should blame me for a lot of different things. You have to remember, there was so many. Okay, I'm going to tell this last story and then we'll talk about trailers.
Okay. Yeah.
We had so much going on that night at that event. There was a hangar on the other side of the parking lot that used to be a jet engine test lab. We had an entire second vehicle's worth of components sitting there on a lift. in case this first prototype failed, I could go out on my drive loop by myself instead of with somebody in the passenger seat. We're all taking a 15-minute break to see Anthony Kiedis perform on stage.
Right.
While I'm changing the powertrain on this prototype and bringing it back out. Fortunately, we didn't have to do that. But I had that rest of that night full of, like, I knew Arnold was coming that night. I knew, like,
the governor at the time.
Everybody was coming. Like, one of my biggest heroes, Rick Rubin, was coming. I was like, holy crap. Like, I want to show him our sound system, like all of this stuff. So I was very careful with that car. But then towards the end of the night, we had a lot of fun. We were doing drifting in the back parking lot. That car is fast.
Yeah.
It wasn't as fast as a modern Model S.
Sure.
But you have to remember, it had a 80 something kilowatt hours in it, a battery pack, and it had a Roadster motor.
Right.
And it was relatively quick. It was good.
Cool. Awesome.
Before we get into Range.Energy, your new hustle, and we're gonna just jump over the Google and the Zoox and everything, just get into that. But
we don't want to talk about level 5 autonomy.
We'll get there.
Trailers, please.
You have this racing background. You have this BMW, this Dinan, this whole thing.
Yeah.
You like EVs?
I love EVs.
What are you driving? What's your daily?
R1T.
R1T.
Baby? That's it. Okay, that's it. Okay.
R1T.
You don't own a Tesla?
No, I don't.
Did you?
I had a Model Y for a while. Great car.
Okay.
It was too much of an appliance for me.
Okay.
Do you own a mint green Porsche Targa?
Yes, I have now one of one, because there were two. There was one in Hamburg that just got rear-ended on a test track. So one of one manual mint green 991.2 Targa GTS with a bunch of roof parts all over it.
So you left with some equity, is what you're saying when you...
I work very, very hard, and I will say that every piece of fortune that I've had from my companies has gone into property and into my kids' bank accounts.
Good. Yeah, and his wife's a Google founder,
Yeah, your wife's Google pre-IPO.
I had a lot of friends at Stanford that were like, "You should invest in this company, Google." I'm like, Google? That's stupider than Yahoo.
We'll ask again. Do you want to sponsor this podcast, or your wife, or your kid?
Right, your kids.
Would they want to?
All these kids.
Last question. You have any thoughts on how's Elon now? You talk to him?
I don't talk to him now.
Can you pick up the phone and like say hello? Or?
No, I haven't seen him in face-to-face in several years. I'm sure if I saw him, we'd high five and how's everything going and move on. He's definitely aware of the company that we're building. His team is very aware of the company that we're building because it really helps the Tesla Semi program as well. But we work together. We would talk in the hallways and text messages like in the middle of the night and stuff like that. And I did, get to travel around and on the road show with him and stuff like that. We were never like personal friends.
Never chew you out in a big way?
Yeah, he's chewed me out.
Oh.
Yeah. He's chewed me out. He's invited me to come with him to Burning Man. All of the both sides of the emotions. Yeah.
Okay.
Yuck to both. All right. Yes. Pitch us Range.
So Elon knows about Range.Energy. Tell us. What is Range.Energy?
So worked on Model S, made a big impact in the automotive industry, went to Google after that, worked on a bunch of random stuff. After that, I went to
Firefly? You didn't work on Firefly.
I worked on the very, very first vehicle architecture for Firefly as a consultant within Google. So
that was a little pod car, little dorkmobile with the smile on his face and the soft nose.
Roush built.
That was a Roush, but that was autonomous.
Yes, that was the first kind of little level 5 autonomous thing. The Firefly team was a different team than the team I was working in. I was working more on the devices and R&D team. But they knew I was an automotive person. So on the first few Firefly kind of brainstorming sessions, they pulled me in on vehicle architecture. And anyway, so spent time at Google. After Google, I went to Zoox. Zoox got acquired by Amazon. I was running the vehicle prototyping again at Zoox for the Highlanders and the Level 5 Robotaxi. And after the Amazon acquisition, I started to think, well, what can I do that has a more near-term impact than the potential for Level 5 autonomy? And I started to look at the commercial vehicle industry. I really became passionate about this kind of idea that the commercial industry only is about 5% of the vehicles on the road, but accounts for 20 to 30% of the harmful emissions. So it's got an outsized negative impact.
And these are big diesel trucks.
These are big 18-wheelers.
Yep.
The truck is in the front, the trailer's in the back. And could I build a piece of technology that has an outsized positive impact that cleans up better than the gas that it saves? And And so I started to look at the Tesla Semi, I looked at the Freightliner e-Cascadia and the Volvo stuff and everything that was being built, and in addition to infrastructure. And I just saw that one thing was being left behind, which was the box, the trailer itself. In every single case, the trailer is still a dumb box. Right. And every piece of technology that's being slapped into the cab is so that it can control the box better. Well, why can't we just make the box control itself, leave the cabs alone for now, let them eventually become electric, hydrogen, whatever the world dictates.
Right.
Or a mix, which is what really is going to happen.
Right.
Let that all happen, and let's build a piece of technology that helps all of it. And so if we can get that box now to make itself weightless in all times to the tractor, to the thing that's towing it, then that tractor can have a far lighter, a smaller burden. So as an example, we take a standard Freightliner Cascadia with a big block. And by the way, I have this working on my Rivian as well with a small scale bumper pull or kingpin trailer, no problem.
Because it's fully scalable, the
260 miles on my Rivian, towing my race car on the back of it.
Yeah.
No problem.
Nice.
One charge.
Nice.
What we do is we basically say, here's your truck and trailer, full-size 18-wheeler. We electrify the trailer itself with our range system. This includes an e-axle, and not a small axle. This is a 300 kilowatt or 350 kilowatt peak e-axle. Same e-axle that's used in things like the e-Cascadia up front. We add a battery pack, 300 kilowatt hours, not 600 or 800 or a megawatt hour, which is what's being put in the tractors.
Right.
Because we're not a primary mover and we fail operational. So when everything falls apart, or if everything shuts down, we're just a freewheeling trailer.
Right.
So you just have that extra burden of about 5,000 pounds. So those are the two core elements, but the key to this is our ability to control. And this is where the unique piece of range comes in, is that our ability to control, again, goes back to those first principles thinking. Originally, we're like, do we connect a CAN bus? Do we do cameras? Do we do all of this other crazy stuff? And how can we get to functional safety? And we want to kind of be in that like level 5 domain of functional safety, or as close as we can get. Well,
which means what? To break that down for the level 5.
Basically, what that means is that we are minimizing the opportunity for this powertrain to do something we are not expecting it to do. And we're doing it in a very, very specific way. And we're doing it in a way to where we can actually interrogate, in the engineering term, all the way down to the chip level and make sure that we have consistent communication, redundancy, all of those bits and pieces, so that we can always have a closed loop of feedback. So for example, if we say something that has functional safety, basically when I'm pulling on something, if I'm just pulling on it and the trailer is just helping, it's not really safe if I don't know how much it's helping and how effective that help is. Right. But then we close that loop through the system to make sure that we're safe, so that if all of a sudden we're pulling our powertrain, so essentially how the system works is no CAN connection, no data connection. At that mechanical connection, the hitch, or what's in the industry called a kingpin, at that mechanical connection, we measure the forces in real time between the tractor and the trailer, or the truck and the trailer. Huh. And as the truck starts to pull, we can see what direction it's pulling, how hard it's pulling. We can see the inclination of the trailer. We can categorize what's happening. Are you going through an intersection shifting? Are you going around a bend? Are you going downhill or uphill? And then based on that categorization, we assist in that trailer to make it feel weightless in real time, all the time. In regen, and when you're slowing down, we actually turn the regen up on the axle, and we actually act as a second braking system. So now you can do one pedal driving on your semi-truck. Your brakes are cold. You're going down the grapevine at 55 miles an hour. The trailer e-axle, where all the normal load is the highest, where all the stability is the best because you're holding from the back now, and the weight is all back there, 60,000 pounds back there versus 20,000 pounds at the most up front. Now that is holding everything down, putting 10, 20, 30 kilowatt hours back in the battery pack, just coming down a grade like the grapevine. And the run between Bakersfield and Las Vegas, this is one of our kind of standard tests. 2,000 foot net elevation gain. Right. Typically on our Freightliner, we have a 2022 Freightliner Cascadia with a bigger block engine, sleeper cab. typically get about 6 or 7 miles per gallon nominal driving with a loaded trailer.
With a loaded trailer. Okay.
With a loaded
not
trailer.
Bobcat. Like
No, yeah. With a loaded trailer, and I would say around 60% load, not fully loaded.
Sure. But that's a typical.
Yeah.
You're hauling
6 to 8 miles per gallon.
Doritos to the casino.
That's right.
Yeah.
Yes.
Okay. Yeah.
Our tractor trailer did that with 15.1 miles per gallon.
So it's nearly triple.
It's about double. It's double.
Okay.
So our
6
baseline numbers are that we can double your fuel economy and reduce your emissions by 70%. And the reason now, when we go back to that outsized impact, what we do is now we use modern robotics and intelligence to sense, okay, well, this tractor now is in between a shift. So we're going to torque fill so that the transmission has less work to do. We can actually shift now in the semi-automated transmission in about 500 milliseconds or half a second, where it would take a second and a half before. And then you all know this, when the emissions, when you take your foot off the throttle and then you put your foot back on the throttle, the engine controller is dumping a bunch of fuel all over the place to keep the piston from melting.
Right.
And this is where a lot of that black soot comes from.
Right.
And now there are particulate filters. And by the way, we don't see soot coming out of the tailpipes. It's there, everybody. It's just being caught by a filter that then gets thrown in a dumpster later.
Right.
It's not in the air yet, but it will get in our water.
Right.
And so, and not only that, the brake dust, all of that stuff that is washing off in our roadways, we're putting all of that energy back into the battery pack.
Right. And there's no modification whatsoever to the tractor.
Zero.
Whoa. How does that work? Because I love this. Go back to you're not using CAN bus. There's no other physical connection.
Sensor on the kingpin.
So there's a sensor on the kingpin. There is a modification at the where the mechanical connection between the truck and the trailer.
We are not modifying the kingpin.
Okay.
The kingpin has ISO standards. It's got safety stuff. We want to make sure that the fleets can still weld on it and work on it and repair it and all of that stuff.
It's not some like giant. I was imagining this is a giant hockey puck like sensor that goes right on top.
If this was 10 years ago, that's probably what we would have to do.
Okay.
But with modern sensing, modern automotive compute, and with an understanding of robotics that we have today as an industry and as a society, we are able to do this in other ways than just measuring pure strain.
This sounds like it's something I'm asking about the core IP right now.
It's in our patent. You can go read our patents.
Are you going to tell us at all? Is there anything like what is it? If I were to look at it, or if I don't know anything.
It looks just like a standard kingpin. The thing is that I want to roll this trailer. Like one of the things that we do when a customer calls and says, "Hey, we want to try your trailer out," we go there. And at this point, we have a really good inventory or understanding of what's in the yard. We take pictures of toolboxes. We talk to the mechanics. We make sure this trailer is not scary to anybody in the yard.
Right.
And that includes making a kingpin look exactly like it did before. And in fact, can we just, as Elon taught us in the old days, the right part is no part.
Right.
So yes, we can instrument the kingpin. And in fact, in our first trailers, the kingpin had a bunch of strain gauges all over it and all of that stuff. And now we have a more integrated system. And in the future, we're going to have an even better system for some new technology that we're rolling out. But the goal here is to have this trailer be ubiquitous across every fleet and every single tractor in that fleet. So even if you put a kingpin plate on the back of your mountain bike, you'll be able to tow a 53-foot trailer that's loaded up to 60,000 pounds with no problem.
So So that's the king.
It's true.
That's the king.
Can I do that?
We actually have a K truck in our lobby.
Yeah.
And we're going to put a kingpin plate on the K truck. I'm just trying to find out how I'm going to get tires to handle that normal load. We may put casters on the outriggers for the trailer itself so it doesn't fall over. But it absolutely, you guys come to Mountain View, I'll put you behind a 6,000 pound or 7,000 pound trailer and you can walk it around like it's on an air hockey table.
Just pull it with your...
Yeah.
Huh.
We call it shopping cart mode.
What is that's wild.
Feels like an IKEA shopping cart.
So the rest of the trailer, where's the battery? The battery is slung
underneath on the outside. So we take up no physical volume of the trailer.
Right.
We add about 5,000 pounds total to the system. About over 70% of the loads on the road are cubed out versus massed out, which means only about 25 to 30% of the boxes that are on the road run out of mass allowance. And these are just like beverage distribution, for example. But guess what? The heavier your load is, the more the assist is. So if you have a fully massed out load, we're actually not 50%, we're 70% better on fuel economy. And so the economics kind of work backwards in the same way that an electric vehicle gets better economy in the city on stop and go than it does on the highway.
Sure.
It's the same type of thing. The more we can stop and go, the more we can reclaim that kinetic energy, the more the trailer adds to the efficiency of the entire stack. So even though we're taking one pallet out of the Coca-Cola or PepsiCo or whatever beverage trailer, the unit economics are so good.
Yeah, the fuel savings.
Every 14 loads, we have to take one extra trailer. Fine. We're saving over 50% of our fuel bill.
Right.
So this is fascinating.
We have to talk about charging.
Excuse my trailer ignorance, right? So this is essentially like 3 Lucid Air battery packs slung, right? 100?
No,
Lucid is 112.
Lucid is 100. This is like 3 P100s.
Yeah,
3 P100 batteries slung between the hitch and the 2 rear axles.
Yep.
And like this is where on some of these trailers you'd see those aerodynamic, like those side skirts.
Right behind the side skirts.
Right behind the side skirts.
You don't even see our stuff. It's hidden behind the side skirts.
How tall are we talking? What's the stack? What would the stack drop down to be?
It's around like 18 or 20 inches.
Okay.
So you don't even see it. When the skirts are back on, you don't even see the system.
Okay.
And the slider, you remember, so one of the things to remember is that if you think about a big rig on the road and you think about the box that's on the back, that's the trailer.
Yep.
And it has those 2 axles, that's the suspension tandem. We call it a bogie.
Yep.
That suspension tandem is meant to move forward and back relative to the box based on how it's loaded so that you can balance the load of the trailer.
Right.
We maintain that functionality. In fact, we automate that functionality with our system. We can't automate that functionality with our system. It can be because we have an e-axle.
Right.
So all we have to do is just retract the pins and then use our e-axle to just drive the system up to the right point. And because we're measuring at the kingpin, we actually know what the trailer load is. So the driver doesn't even have to hop out of their trailer to balance their load.
But if I've got 3 Honda CRXs and I want to steal some DVD players, they can't fit under the trailer anymore because the battery.
That is a problem.
Okay.
Well, that's a safety
theft prevention.
The challenge. Okay. You need to go to NSX.
Yes.
Right.
Dumb question.
3 Countachs.
Yes. Which axle has the e-axle?
Currently, we are electrifying the forward axle.
Okay.
But our system has modularity. We can electrify either or both. There's a bunch of different things, but our first product is a very basic, straightforward system that is meant to service the refrigerated industry and the dry van industry. Refrigerated industry is where the most pain is, especially in places like Southern California.
Why is there pain?
Because one of the things you have to remember, a refrigerated trailer has that kind of refrigeration unit on the front. It looks kind of like a scab or something on the front.
I'm learning this for the first time. Okay. I'm not remembering.
So if you look at these big trailers and you look at the very front, in between the tractor or the cab and the trailer itself, it can either have a flat surface or it can have that kind of domed refrigeration surface.
Yes. Okay, that's what that is. Yeah.
One of the biggest problems with, especially in places like Southern California, is that to keep that box cold, the refrigerator has to run. That unit has to be running. What most people don't know is the bottom 2/3 is a diesel engine burning about 2 gallons an hour, just sitting there.
Right.
We remove that entire diesel engine. We use our e-axle as a generator and the battery pack as the power storage. And so now we can actually sustainably run a reefer unit, a refrigeration unit. And now this solves all of the dock problems, a bunch of the different problems that are around zero emissions refrigeration. And that's why we have a partnership with Thermo King, is because we are the only solution currently that solves that problem to go pure electric.
I'm sold.
We break down in Needles, California. It's 117 degrees.
Yep.
How long with 300 kilowatts could I run a reefer unit?
Our current model shows anywhere between 20 and 30 hours is the last that I remember. But so at least, and that's like during the day. So we can, you can stretch it. You don't need to always be running the compressor, like a bunch of different, it really depends on the efficiency of the box. And
keep the refrigerator door closed, kids.
That's right.
Yes.
But you're not burning diesel.
Exactly.
Not burning diesel. Now there is an exception where, for example, we've even been approached by like DOD and like Red Cross to build mobile command centers out of these trailers.
Sure.
Like this is the power infrastructure. And then they're like, what do you do if you're in the middle of the desert and you can't get solar because there's a sandstorm or something like that? Hook it up to a diesel tractor and go for a 1 hour drive. We go to drag charge.
Right.
We put the energy back into the battery pack and go back and park it and run your hospital again.
Right.
So those are all future applications of, niche applications of this type of technology. But currently we're laser focused on the refrigerated and the dry van, material movement, commercial trucking industry for specifically the Class 8 trailers.
Let's get back to hopefully some of the guys. I don't know if we have a big trucker audience. I don't think we do.
No,
but
we definitely don't.
Explain sell it to me like I'm Sylvester Stallone from Over the Top. Like when you talk to the drivers, what's their benefit?
These are our biggest fans.
Yes. Oh, great. If they're skeptical, what is their skepticism?
What are their initial concerns?
And then what do you win them over with?
Yes. So the drivers, you have to remember, I came from racing and I was a race engineer. And one of the first things I learned as a race engineer from Carroll Smith himself, the guy that wrote all the great books, was that your job as a race engineer is to get the driver as confident as possible behind the steering wheel. You drive race cars, you know that.
Not very well, but I do.
But right? The more confident you are, the more performance you're going to extract from that vehicle. It's not about my tires aren't like. Let the engineers think about what the tire pressure looks like and what the tire temperature gradient looks like and all of this other stuff.
No, yeah. I mean, this happened when the other week. I was like, hey, something's wrong with the rear end.
That's right.
I came in and 2 minutes later I was back out and it was fixed.
So
whatever it was.
Taking that over to where we are now. In this entire stack, the most important group of people are the fleet operators and the drivers. These are the folks that are actually doing all of the hard work that allow us to take delivery of these microphones and everything else that we love every single day. And so, and because I've been driving trucks and trailers since I was 14 years old, I have this like very specific, and we all in my company have a very specific empathy for the driver and the fleet operator. And so what we do is we actually tailor all of our driving algorithms, all of our assist algorithms to give the driver confidence and safety. We have anti-jackknifing stuff. We have a bunch of different bits and pieces. When we torque fill, we never pull confidence away from the driver. We give them confidence. We get quotes like, holy crap, you turned my old Freightliner into a new Tesla. Thank you. And so now the drivers are fighting to drive with our trailers. And it's really because it gives it, imagine you're a driver, you're sitting at an intersection with even a 3% grade, you're fully loaded, and you're waiting for the semi-automated transmission to shift into its next gear. Well, you can accelerate up the grapevine at 55 miles an hour, fully loaded at 50% throttle. There's no other truck and trailer in the world will do that. Not even a Tesla semi when it's all loaded up. And so maybe a Tesla semi will do it, but pretty much nothing else will do that.
Right.
Well, so that steady state climb sounds interesting, but when you're leaving an intersection and the driver's got to do whatever the 15 gear shifts just to get across to the next light, does this it just smooths it out completely? There's no
it makes it feel like you're shifting in the parking lot, just completely standing still, and everything just goes right into gear.
That's the torque fill.
That's the torque fill.
Oh, okay.
Imagine the first time you drove, I don't know, if you drove a modern Porsche with the blip shifting on the downshift, and you're like, oh, that makes it a lot easier.
Yes.
Right? And everything just kind of falls into place.
Right.
And so we use our intelligence to do the torque fill specifically to give the driver confidence, to give a uniform sense of torque, but also to pay attention to those torque transients inside the transmission. So whether you have a manual or a semi-automated transmission, we multiply the service life by a lot in these vehicles because we're not requiring these huge torque transitions.
Yes, no shift shock.
So how much? What's the cost? If you're making everything better.
Well, let's talk about charging for a second.
Yes, how do you charge?
Right,
I think so. This is something that I'm particularly proud of because one of the things that I noticed early on was that if you have these tractors with 600, 800 or megawatt hour of energy, 600 kilowatt hours or megawatt hour of energy, charging infrastructure has to scale up as well. Well, we all know that there are 150 kilowatt chargers all the way up to 350 kilowatt DC chargers kind of all over the place at this point. And you can pretty much, short of buying them on Amazon, you can get them when you need them. Nobody's able to give us 600 kilowatt or megawatt DC fast chargers on a regular basis. They're hard to get. The infrastructure is very difficult.
Right.
This is why we have a 300 kilowatt hour battery pack. And in some cases, in fact, we have a specification for a 200 kilowatt hour battery pack. Because we have these smaller battery packs, we can now utilize automotive levels of DC charging. Still use commercial hardware there, but we use automotive levels of DC charging, 150 to 350 kilowatt DC chargers. And now we can actually use the shore power that's already at the loading dock. And unlike tractors that are burning money when they're parked and charging, the trailer has to be parked to get loaded and unloaded. You're not going to throw things at it.
Right.
So it has to be parked. And so what we did was we did a survey of the fastest fleets. The fastest fleets are the Amazons and Walmarts of the world. These folks load in at around 40 to 45 minutes a box. Can we charge our entire trailer in 45 minutes? Well, yes, on a 300 kilowatt DC charger, we can get to 80% SOC in 45 minutes.
Yeah.
No problem.
Yeah.
And now we become operationally transparent. Using power at the building. The buildings already have power. The problem is when you need to call SoCal Edison to trench 2 miles from your substation to this new lot that you just bought to charge all your diesel tractor, your electric tractors that are way out there.
But how many, it's because I'm imagining a Walmart distribution center and the lineup of those trailers. You couldn't plug all of those into the building power.
It's regulated. So all of the new loading docks, especially ones that support refrigeration, have to have this power. And a lot of these folks are more than willing. Like our first pilot, we used employee charging and just pulled the cable over the fence and plugged it into our trailer. So we have incredible charging flexibility. We even tell our fleet drivers, worst case scenario, just pull it up in front of your house and run a cable from your dryer into our trailer and it'll charge.
Yeah. Well, because, so 300 kilowatt hours, the Hummer and the Silverado EV, those batteries are, I don't know, usable is like 212 or something like that. And they charge fast, you know, and so I remember, I had to take one to 100%, but it did it in less than an hour.
Yep.
So if you just get to the 80%, because that's where,
Well, I just remember when Kyle was here, like when everyone thinks you can just go to this bank of 350s, but the minute 2 are on there, that station starts to split the power.
Right.
But it's going to be different at a dedicated.
Yeah, absolutely. The one thing that's great for us is that we're working with fleets. And these fleets count by the second, by the mile, like everything is super important. And so when we show them a tool for their operation that's going to make them more efficient, safer, whatever, they'll figure out a way, and we help them figure out a way to incorporate this tool into their operation. And then you get predictability. And with predictability, then you can start thinking about, where do I charge? I only need to take it to 60% on this part of the route, and then I take it to 80% overnight, right? Because everybody that drives an EV knows that, obviously we would all love to just go from almost no range when we get to our house to 100%. But most of the time it's like, all right, well, I'm at 30. I don't think I can charge for the next 2 days. So I'm just going to get to 50 here. And then I'm going to drive for a few more days.
So then what's in the cab for Sylvester Stallone and his old Freightliner? Like then the Kingpin hasn't changed. What's he looking at to see all this?
So we have a whole data backbone, and these fleets are inundated with folks that are developing new data platforms and telematics and sensors and cameras and all of this stuff. We do not want to make that any more complicated. So we've partnered with a company called Cebros, who does a bunch of back-end work for us. And essentially this now is the pipeline that we need to do the quote unquote software defined part of the vehicle itself. So now, instead of us saying, okay, fleet, you need to put a new screen in your cab for our stuff, we say, do you have a screen in your cab? Yes. This is the CAN information from our system. It's up in the sky. You take it into your fleet manager that's sitting at home. That fleet manager can then say, okay, driver, this is the information I want you to have. Or just like a refrigeration unit, you don't know any information. You just see 3 lights in your rearview mirror that says green, yellow, and red.
Good to go. Yeah,
and most of the drivers just want that. Okay. And so we don't want to complicate things. The right part is no part. Remember that.
So but we'll get to how much in a second. But okay, so you're saving over half in fuel.
Yep.
But how much does it cost to keep these things charged? Like, you know what I mean? Like how much of that
nets out? So 70% reduction in fuel, or increase in fuel economy, and 70% reduction in harmful emissions. And then essentially that is net. Like when you start talking about like let's just I guess the easy way to say this is we have a calculator on our website, and that calculator basically goes through and it takes into account your cost of electricity.
Okay, and that
your cost of fuel. You put all of those metrics in.
Right. Okay.
And then it goes through the unit economics for you.
Right.
And then we also have a more deep version of that, which is essentially the raw Excel spreadsheet. And when we engage with a pilot, then we sit with the decision makers in the fleet, and we say, okay, this was the data that we saw from the pilot in your own routes with your drivers, with your tractors. So we know the data is real. Then we run it through that calculator with how much they pay for fuel, how much they think they're going to pay for fuel, how much they pay for electricity, all of these bits and pieces. And we say, these are your savings.
Right.
And so that number is anywhere between 50 and 70. It could be 30 in some cases. It could be 80 in other cases.
Gotcha.
It's just really kind of fleet specific.
Depends on the specifics. Okay.
Yeah.
Okay.
So how much?
We don't talk about pricing out loud quite yet.
Okay.
But typically these fleets are looking for payback. What's my ROI? What's my cost per mile? Like all of these things.
Okay. Well, how many
And
miles?
we typically, so if we look at some baselines, right? Typical fleet has 3 trailers per tractor.
Okay.
Okay. And to just kind of put a sense of scale on things, JB Hunt and I think Ryder, they're right around 120,000 trailers. Walmart, Amazon, around 80,000 trailers. And then it kind of goes down from there. Let's say, I think Reyes Coca-Cola, that does all the Coca-Cola deliveries for down here, I think they have around 3,000 trailers. So there's a huge kind of breadth.
Spread. How much is a trailer? Like, how much is a current like dumb trailer?
A basic dry van trailer is anywhere between $50,000 and $60,000. Okay.
And the tractor?
And the tractor for a diesel tractor is about $175,000 to $200,000. You guys know how much an electric so Freightliner Cascadia, sleeper, big block. Actually, I'm sorry, day cab Freightliner Cascadia is around $150,000. Electric Cascadia, $475,000.
How much is it? Tesla?
No real prices have been
I heard
announced yet.
$500,000.
Yeah, it's between $500,000 and $600,000 is kind of like the estimate. Anyways, long story long. We try to give our customers a 3 to 5 year payback on the trailer. This is the first time a trailer is able to give you money back. So after about 3 years on a refrigerated trailer and about 5 years on a dry van, not only are you net zero, now you're getting money back because you're using less fuel. And now this formerly depreciating asset is actually making you money more than just moving goods around.
And if you listen to the Mobility House episode, if you got a whole bunch of these battery packs and you can plug them in at different times of the day and give energy back to the grid
balancing,
you might actually make some money on top of that just by smart charging.
And our trailers are mobile power stations, so they do have all of that infrastructure. At a track day that we did at Sonoma, we were charging vehicles off of our trailer as a demonstration. So
it's wild. Okay.
That's very cool.
We gotta go. We're way over. It's great. I could keep going. We're gonna have you back. We'll talk about
I was going to suggest part 2, but
just one question. Because you kind of alluded to it. You mentioned Tesla. Does this help a Tesla? Why would Tesla Semi be interested in this? For all the same reasons?
Well, I think, we really strive to be complementary to all of the different efforts. I think there's no reason for us. We're all kind of up against the wall now. Or up against the ropes, as they say,
or out of the ring, but
out of the ring as an industry. We're on the side of the ring, on the ground, waiting for Joe Rogan to stop yelling in our face and get back in the ring. And
quite literally, go ahead.
literally. And so I don't want to build a piece of technology that alienates or isolates another person's efforts in this direction. And yes, there are definitely areas that I think are not going to be as successful as other areas, but we have developed this technology to be complementary across the board. So as an example, you have an old diesel fleet, we'll make that old diesel fleet work a lot better. Your maintenance costs are going to go down. Your fuel costs are going to be much better. All of that stuff. You have a brand new diesel fleet and you're a hypermiling diesel trucker. Great. We're going to get you to that 20 miles per gallon with your system and your hypermiling. Wow. And if you have a Tesla Semi or Freightliner e-Cascadia, and there's a bunch of photos of you and your fleet stuck because you couldn't make it that extra, 20 miles because you're only at 120 miles before you run out of charge and not that 180 that Freightliner claimed. Well, the most important piece for us is that we double the range on a Freightliner e-Cascadia. We increase the range substantially on a Tesla Semi. And we're in the middle of doing more and more exhaustive tests so that we can publish those numbers publicly so that people can see. I just spent $15 million on this fleet of electric semis, and now I have to park them because none of my drivers want to be stranded in the middle of their route. Well, we can recommission all of those tractors, and we can help increase the utilization. And in the future, you can't even do long haul electric trucking without having an e-axle and a battery pack in the trailer. It has to be a complete system, because that extra e-axle in the trailer is what's giving you the extra capacity to regen the most efficiently across the system. Because those e-axles that are in the tractor, they run into regen capacity very, very quickly. And then they have to shed a lot of that energy to the friction brakes. We're putting that e-axle, same power, in the back where all the normal load is the most. So we can actually turn the power way, way up on the regen and reclaim a bunch more of that energy. So long haul electric trucking has to have an electric trailer.
And then can you, if you have a electric tractor, would you ever be a way to like link the batteries?
You could.
Or is there a purpose to that?
I don't think there's a purpose when you have the road to be able to transfer energy.
Okay.
Right? When you have an e-axle in the trailer and a tractor, you don't necessarily need to, because you can kind of exchange energy through the road. It's not the most efficient way to do it.
Well, could you do bi-directional, like,
yes.
in other words,
so
like...
you could, but it will require a really unique battery
cable
architecture. No, because you basically have to be able to feed power while you're charging power.
Yeah.
And so you kind of have to have like a split battery architecture.
Got it.
Where part of the pack is working to give you energy, while the other part is working to receive
energy.
it.
Yeah.
Well,
sort of. Yeah,
two batteries that smash together. All right. I only have a couple of really short questions. Do you have a Class A? Do you have a Class C? Do you have a commercial driver's license?
No.
Oh, should we get one?
No.
You know, so I'll tell you, I say I've been driving trucks and trailers since I was 14. These are all like farm trucks and trailers, race car trailers, definitely a lot of commercial stuff without a commercial license.
Sweet.
But I am in no way a truck driver. I'm not a professional. I have so much freaking respect for those folks. I went through the process to get my Class C. I also drive a lot of fast sports cars. Yeah. And if you have a commercial license,
and
1
you get a speeding ticket, is
real bad. Zero tolerance, double points, like all of that stuff.
Also, the 0.08 for alcohol goes down to like 0.0.
0.00.
Yeah, it's 0.0.
I don't drink, but get it.
There's a lot of restrictions.
Yeah. It becomes very, and then also there's a whole bunch of other stuff related to other things that I have a lot of great drivers on my staff.
Okay. Second question, but going back to the Tesla stuff, would you recommend, like, I'm a weirdo. I know it's impossible because I think we looked up the VIN. I wanted to go back and buy the original Model S, the 2013 Model S that we got from Tesla way back when we had it for a year-long loan. Would you recommend buying those early just to screw around? Because they're getting real cheap.
Yeah, they're so I have many times thought about buying a P85 Plus.
Yes.
Rear-wheel drive.
7-seat.
Big battery.
I want 7.
So you can get the 7-seat.
Yeah.
Has good suspension. It's a great car. And, you know, a lot of people talk about battery degradation and all of this stuff.
Don't care.
The next time any of you are in Las Vegas and you get in any Tesla, especially a Model S or a Model X, ask the guy how many times a week he fast charges. And it's at least 2 or 3 times a day that he's fast charging.
Yeah.
And then look at the odometer. The last one I got in was 230,000 miles. And the guy said he supercharges every day. And he has 86% reported capacity of his battery.
Yeah. I tell people who ask this all the time, like, oh, the battery's so expensive. Have you heard of any widespread battery failures from any OEM? No, you would hear about this.
It comes down to 2 things.
Yeah.
Super clever software controls to make sure the battery is balanced and happy and all of this stuff, and super clever thermal management. If you can charge and discharge when the temperatures are right, you can make that battery last a long time.
And I was going to say, too, that's like supercharging 3 times a day is very abnormal. That's why, like,
it is.
Most Model S's have over 90%, even from a decade ago.
Exactly.
Like way over 90%.
Yeah.
But there's nothing else hardware-wise that you'd be like, it's a little suspect.
Roadster, a little bit. Okay. Just because there's, that early stuff was really computer class hardware that we put in a vehicle, and like, we're like, oh, this chip's not going to fall off if we just like put epoxy over everything. Okay. And so like, there's a bunch of that kind of stuff, which worked for Roadster. I really do think early Model S is not a bad thing.
All right. That's all I need to
hear.
hear.
If you can get them for cheap.
Okay, which you can. Well, we're way over. We could go on all day long.
Are you thinking about a Gen 2 R1T?
I have been definitely thought about it.
Yeah.
I like my truck a lot. And
do you know your VIN, like the last 4 digits?
No, I don't have it off the top of my head.
We'll talk off the
air.
Yeah. I have many thoughts.
Yeah. I have the second wave of cars. So first order wave, early pricing.
Yeah.
Second delivery wave. So there was like a first.
What month in 2022 did you get it? I got mine in June, but it was ready in May.
Yeah, I got mine like October, November time frame.
Okay, so you're probably like in the 6,000 or something like that.
Yeah.
This is weird. You weirdos.
No,
Okay.
things got different. Like the early builds are kind of.
Well, I mean, that's just typical startup. Like you want to get the first cars or the second cars. You don't want to get the cost down version of those vehicles. But you know, I have so much respect for Rivian. Like I think the products that they're putting out and the team, like I have a lot of friends there as well.
Sure.
But I really think that like the R1T is impressive as a first product for a new company that is relatively quiet on purpose, and to just bring a vehicle like that out and it just works. Like I have beat the crap out of my R1T at Prairie City Off-Road Park, jumping it, treating it like it's a side-by-side, like, and like, okay, kids are in it. Like it works every time.
That's the crazy thing is like, you know, you do that like crazy, like rock crawling, like, you know, double black diamond rock crawling, and then take the kid to school, and then I blasted up a canyon, you know, passing Porsches.
I want a G-Wagon, like a 2009 G55 or something like that, naturally aspirated V8. But I just think to myself, like, when would I ever drive it? I have my Rivian. Like,
right. Well, have you driven the electric G?
Not yet.
Take the electric G off road because it might be. I know. It might have out Rivian with that thing. It's pretty wild.
All right.
Yeah.
Ollie, I got 100 more questions. We'll do them off the air. Range.Energy is the site. These all those products about savings calculator, contact. I don't see an invest here button, but we'll talk about that offline.
It's one of those if you have to ask, then you may not be able to afford
exactly.
Are these on sale yet?
So we have opened our order books for customers.
Okay.
We have actually sold our first trailers to Petaluma Egg Farm in Northern California.
No kidding. Oh, that's great.
Super happy to have them on board. We have gone through a handful, about half a dozen strong pilots with very, very big names. And those pilots are going to start converting to sales. And essentially we're at the very beginning stages of booking sales. We have a bunch of customer interest, and now it's like, prove it.
Right.
Okay. And that's what we're doing.
Well, dude, good luck.
Thanks. Thank you so much for having me.
Oh, yeah. This is awesome. We can talk forever. We'll have you back after you're a billionaire and your name is on the sponsor of this podcast.
After Freightliner buys you.
That'd be great. Ollie's kids. Keep this laughing going. Just laughing. This is the part that will get used in the future episode. Ollie Javidan, Range.Energy, thank you so much for coming on.
Thank you.